Hey kids! So, you like learning about chemistry? Well, you're in luck. Welcome to the Chemistry of Extravaganza with Fritz and Friends for Kids. Now, let's get started.
No, just kidding. Have you ever wanted to know why you cry when cutting an onion? Well, kids, it's pretty simple. Once an onion gets cut, it releases amino acids, which eventually convert themselves into sulfenic acids. These acids transform into gaseous S-oxides once they are released. When this gas reacts with the water in your tears, it creates sulfuric acid, which burns your eye. This whole process is an example of an acid-base reaction, with the sulfenic acid from the onion reacting with the water from your eye. Now don't start crying, it's just the onions.
Nobody loves me. Fred is my really friend. Beth. Sheen.
Boring. Let's talk about something a little bit more interesting. Tires. Tires are how we transport everywhere. Cars, bikes, planes. The proper pressure in a tire is between 30 and 35 psi. Now let's talk about the pressure a little bit. When you add air into a tire, you're decreasing the volume of the air molecules, making all the air molecules packed together. This increases the pressure in the tire. This is called Boyle's law. It's an inverse proportional function, which means as the one pressure, let's take for example, increases, volume decreases, or the opposite.
Stop. Quiz time. Get your pencils out. It's time for a quiz. First question. What's your pencil lead actually made of? Professor Murphy. I'm right here.
I guess no one has the answer. We would have accepted graphite or graphene. What makes graphene really impressive is it's actually one of the strongest, lightest, most electrically and thermally conductive substances known to man. What's more amazing is it's actually just one layer of carbon atoms bonded together in a 2D lattice. Each carbon atom is bonded to 3 other carbon atoms, and the bonds are made between sp2 hybridized orbitals. These layers of graphene are actually just stacked on top of each other, like millions of them in your graphite. And there's van der Waals forces that bind these together in your graphite that allow them to slide past each other and let you write.
Oh, cool. I'm hungry now. Anybody down from the shellfish?
I am. Shellfish are human, both carbon-based creature inhabit of Mother Earth. However, our humans have red blood running through our veins. Our blood is red because of a protein called hemoglobin, which is essential for transferring oxygen in the blood from lungs to tissue. Hemoglobin is built up by 4 subunits called heme groups linked by intermolecular forces. Each heme group contains an iron atom that combines with one oxygen molecule, and the presence of the iron atom makes the oxygenated hemoglobin absorb the electromagnetic spectrum of blue and green range and reflect the red light, which causes the red appearance of oxygenated blood. However, for some other creatures, such as this delicious lobster, having blue blood is the norm. Rather than hemoglobin, this creature uses a protein called hemocyanin to transport oxygen through their blood. Because hemocyanin is more efficient in their natural habitat, cold water with low oxygen pressure. The oxygen binding center of the hemoglobin is a pair of copper atoms, and the oxygen molecule is bridged between them. Hemocyanin bond with oxygen while copper gets oxidized from +1 to +2. When copper is in +1 oxidation state in the deoxygenated hemocyanin, it is paramagnetic, which is linked to the colorlessness. When copper is in the +2 oxidation state in the oxygenated hemocyanin, it is diamagnetic, which leads to the blue blood. The blue blood.
Cooking lobster is actually a perfect example of an endothermic reaction. Tossing a lobster onto a pan, hopefully with some heat butter on it, causes the very structure of the lobster to denature. This is because the proteins inside the lobster that make up the chemical structure of the lobster start to receive so much energy and heat from the pan that their bonds start to destruct and break apart. Other great examples of this include frying an egg, and you see the egg turn white, and frying any other meat, where you also see the meat turn white. These both change colors, which are great examples and the proof that these proteins change structure. Well, what a fun day we've had. I'm ready to go to a nap after a few drinks of water.
That's terrible.
Hey kids, so you like knowing about chemistry? Well, welcome to the Fritz's